Okay, we're going to start with our sedimentary rock worksheet. And what did we start with in our bread lab? How many different pieces of bread did we have?
3.
Yeah, we had 3. So, on these boxes here, you need to color them different colors because if you remember correctly, we had 3 different colors or types of bread. Nope. Okay, voices should be off. And what we did with those different pieces of bread was you guys took the time to break them down into very fine pieces on your paper towel. So, when you draw that in, that was the process of weathering, where you break down rock. So you're just going to draw on your little paper towel over here what that looked like. And those were just those little dots, and they should be the same color that you drew your squares in.
Oh no, I broke it.
Then, after you had it broken down into your little pieces, it was on a paper towel. You had to pick it up and move it. Raise your hand if you can tell me the process involved with carrying that rock away. Chloe, awesome job. That is erosion. That's already listed for you on the arrow. Then, you had to press down on it, right? You applied pressure, and you were left with something that looks like this. And you used some really, really good words to describe your finished product. Does anybody remember what words they used? How did you describe what sedimentary rock looks like? What was a key word you used? Shimmering. Yes, layers. What did those layers look like? Were they curvy and wavy, or were they flat?
Flat.
That's correct. They were flat. So you're going to draw what your end product looked like. Yes, because that's how it looked in your lab, and that's what we're drawing. And you notice that we've included all of the titles there for you. Now, at the bottom of the page, we need to remind ourselves what those terms mean. How are we doing on the coloring out there, Mrs. Irish? You ready to move on? All right, so we're going to move on. You'll notice you still have half the page to take notes on. So, colored pencils down, regular pencil up. For our sedimentary rock, you remember we've been calling this the bread lab. And I think you were all able to tell me that the bread represented rock. But what I want to make sure we have down is our definition of these processes. So we have weathering first. And weathering is breaking down rock. And that's where you took the bread and you crumbled it up into those very, very fine pieces, left it on your paper towel. Those broken pieces and fine pieces were called sediment. And then you took your sediment and you moved it. Moving from one place to another describes the process of erosion. Moving from one place to another is the process of erosion. After erosion, we had deposition. Remember, you spell the word deposit and add an I-O-N, deposition. And we said you deposit, which means put the sediment down. In our case, we put it in a baggie. Out in nature, it's just that sediment traveling and then it gets put down and stuck in place. And the last process is lithification. Lithification was when you applied that pressure. You pressed it, known as compacted, you pressed it and cemented it. That means you pressed it hard that it all got stuck in place, kind of like if it were cement.
But it wasn't.
You pressed it? No, it wasn't. And this word is compacted, C-O-M-P-A-C-T-E-D. You pressed it and compacted it into place. Hereto forever known bread lab is sedimentary rock. We good?
Nope.
All right. So there are 4 processes involved in sedimentary rock formation: weathering, erosion, deposition, and lithification. Alrighty, let's turn our page. We're going to go back up to the top, and in it you have glued in your metamorphic rock worksheet. Now, we use Starburst for our metamorphic rock. You had 2 different colors, so you're just going to quickly shade those 2 different colors in. Voices should be off. What 2 things do we need for metamorphic rock to form? Raise your hand when you've got it. Adolfo, what do we need?
Pressure.
You got it. I draw an up arrow because we have to increase pressure. And we also need heat. And what we saw with our metamorphic rocks was we had some examples of when those starbursts got smashed together. They had kind of wavy layers.
Pretty colors too.
So you're going to go ahead and draw that in. Remember, they're different than sedimentary rock because it was wavy and sedimentary rock was flat. Some peoples also had kind of chunks of different rock in them. So you may see it either look very chunky, and you may see bands where there's really wavy layers. Shimmery, question?
I'm just starting to get like mixed, like the colors are starting to get color.
Now, for the class connection, I just want you to remember that this was the starburst lab. So write starburst. And metamorphic, because there's so much heat and pressure and it's deep in Earth's crust, it's all jumbled up. So underneath here, you're going to write, it can be many different kinds of rock. Or minerals together. So metamorphic rock can be many different kinds of rocks or minerals together. How we doing? We ready to move on? Alrighty. Next page. What's our last type of rock? Igneous. So we're going to turn to our igneous rock. And you'll notice that we have some labels here. What we had was you can take any type of rock, whether it's sedimentary or metamorphic, and it can become igneous rock. But what needs to happen first? What did I do? Yeah, I melted it, right? So you can take any kind of rock, and what we had to add was heat. But underneath heat, you have to put melting, because warming it up without completely melting it is not how igneous rock is formed. It has to melt. Then we have two different types. One is intrusive and one is extrusive. Intrusive means it is happening under the surface of Earth, so it's happening underground, which is magma. Magma, M-A-G-M-A. And extrusive is this molten rock that's on top of Earth's surface. That's lava. And we talked about a few different characteristics of igneous rock. And it really depends on if it cools quickly or if it cools slowly. Remember I showed you, oh, you guys didn't see it yet. I'll show it to you in a minute. We had one starburst that we melted down, and I put that in the freezer. It looks nice and smooth and glassy, and there's not much crystal formation because there was not time. It cooled so fast, there wasn't time for those crystals to form. The other one, I let cool very, very slowly, and you can see it formed really large crystals. And sometimes what that will look like is it looks like it has holes in it. So you could have two different types looking rocks depending on how they cooled. You could have one look very glassy, and I'll show you an example of obsidian tomorrow. It looks very glassy. Or you can have one that looks like it has holes in it, kind of like pumice stone. Looks like it has holes in it and it's very light. So, for this, what I'm going to draw is a rock, and I'll color most of it in, but I'm going to leave some holes in there
I'm gonna leave
so that I remember it'll either look like it has holes in it, and then the other type would be very smooth and glass-like. And then for your class connection, just make sure you put in there what we did in class to demonstrate how igneous rock is formed. We melted a rock, I put that starburst in that hot pot, and then cooled it to form igneous rock. So we melted a rock and then cooled it to form igneous rock. Now, the book describes it as molten. So I want to make sure that you write the term molten in your notes because you may see that again. Molten equals melted. Molten equals melted. Make sure you're writing this down. And then we also should include what magma is. Magma is molten material found under Earth's surface. So this would be underground. Magma is molten material found under Earth's surface. Lava, on the other hand, Robbie, keep going, is molten material found above Earth's surface. This is more the stuff we're used to seeing. When lava comes out of the volcano and runs down the side of that mountain, that is lava. When it's underneath the ground and we can't see it yet, it is magma. 1 second, Jordan. So, what are our three main types of rock? Raise your hand when you have them. Chloe. Shimmery? Igneous. Sedimentary. Awesome job. Metamorphic. We'll pick back up tomorrow with these three types of rock, and we're also going to start warming up about the rock cycle.